Hi, my name is Vishnu, and welcome back to the series. And in today's episode, we'll be learning all about backend, APIs, and database. So let's get into it. Just a heads up, this video is a layman explanation of whatever concepts that I'm going to talk about, so that most of my non technical viewers would be able to grasp the entire concept. So, what is backend? Backend is an environment that is kept separate from the front end environment. In the backend environment, we have APIs, servers, and database. So now the question is, why is front end and backend kept separate? Why do we do that? To understand that, we need to also think of front end as adaptable and backend as strict. So keep these two words in your mind, adaptable and strict. So front end can take many shapes and form. So let's take an example of YouTube. YouTube can be viewed on the web, on your PC, on your TV, on your probably smartwatch if you have that kind of a smartwatch, and your tablet. That adaptation is led by the user's device. Regardless of whatever devices that you might be using to watch YouTube on, you will always witness a synchrony of data between all the devices. That happens because we have a unified database that stores whatever actions that we have taken on the front end through an API endpoint. So APIs are the communicators between front end and your backend. And based on that communication, backend decides on what to do with that data. And the database always acts as the source of truth. When we look at it from a perspective of a developer, they don't have to keep rebuilding backend to adapt it for multiple other devices. The backend is always unified, whereas the front end can be built for multiple other devices. I hope now you have some clarity on how the backend is separate from front end and what all consists of backend. Let's also learn about APIs and database. In this day and age, we have three most popular database structures out there. The first is SQL database, second is non-SQL database, and the third is vector database. Vector databases are used for AI implications, and NoSQL databases are used by a lot of social media platforms. We are not going to dwell deep into these two types of databases. We will stick to SQL databases. SQL databases are also called as relational database. So one of those SQL database example is Supabase, which I used to build Claringo. And within that, I have created several tables, and each table has its own purpose. We use SQL databases because it is easier to manage, it is reliable, the data extraction is also familiar using SQL queries, and also it is reliable and secure. Here, if you see a table and the structure, it looks very similar to Excel's layout, where you have columns and you will have rows with the data. And in the column, we also see the data type which the row is storing. And each table is and can be related to another table. That is what it makes a relational database. This is what a SQL database looks like and why it is used.
Now let's talk about APIs. APIs, as I said, are communicators. And just like humans try to communicate with their peers in, let's say, a different language, symbols, expressions, or probably signs, just like that, there are several protocols or style of communication as APIs. So some of those popular ones are REST APIs, SOAP APIs, GraphQL APIs, gRPC APIs, and WebSocket APIs. I'm not aware of all, but I know at least three of them to give you a better understanding. So REST APIs is what I used for Claringo, and this is the most commonly used ones as compared to data intensive applications that there GraphQL API is used instead of REST APIs. Within GraphQL APIs, you can request a specific data that you need, not the entire data structure as the REST API provides you, but just a specific data line which you might need. And WebSocket APIs are now very popular among AI apps, where if you have noticed, when you query something from ChatGPT or Gemini, you would see a stream of data loading on your UI. No, it's not a UI animation to make you feel like AI is trying to respond like a human. It is just the way that the API is made. There they are using WebSocket APIs, where there's a continuous back and forth communication between the client and the server. We will not talk much about WebSocket APIs or GraphQL APIs. We'll talk about REST APIs today. And let's dive deep into it and understand how to use REST APIs within your apps that you might be building. To understand REST APIs better, we need to also look at the counterparts of the REST APIs. Those are endpoint, payload, authentication token, and methods. When we look at an API, it should always have an endpoint. Endpoint is the URL which is getting called to make a certain API request. So this is an API endpoint which is being called. And within that API endpoint, we have a query parameter, which is after this question mark. We have a path, which is a parameter. For now, this is a user ID. And the endpoint path, which is the users, the version of the API, which is version 1, the base URL, and the HTTP method or the request method. So this makes an entire API endpoint. So this is just an example. Don't get intimidated. You will understand this while building an API. Since we have looked at an endpoint, let's look at another important component, which is payload. Let's understand payload by an example. Let's imagine you are at a grocery store, you have a bag, and we'll assume the bag is the API. And within that API, you have filled in certain items that you might have bought from the store. So those items are payload. And you are now going to your home. So you're probably creating a post request. So basically, you're taking these items from the store to your home. We'll assume the store as a database and your home as your client side or your user side. You can probably bring that payload back to the grocery store. So now you are making a put request. You are going back to the database and changing that certain content. So payload is the content which is sent by an API either to the backend or received from the backend. Now we'll also look at the token or authentication token. So for APIs to work, you need certain token, and that token validates you as a verified user to do certain actions on the database. So if we go back to the grocery example, if you have a receipt of your purchase while returning it to the store, that receipt will act as a user token. Similarly, in APIs, there is a bearer token, which is encrypted in a JWT format. Now let's look at the final component, which is method. Methods are a way to express the intent within the API. So our intent can be creating a record within the database. Our intent can be updating a record within the database. Our intent can be reading a particular record within the database or deleting something within the database. So we also call these methods as CRUD: create, update, read, and delete. And similarly, they're also called as post for create, get for read, put or patch for update, and delete is obviously delete. So if we see few examples over here, view a list of items. So I am using the method called get, and my API endpoint would look something like this, which is get/API/products. Similarly, if I want to view one specific item, I'll still call a get API. And again, I have API, product, and lastly, we are also giving the item number. And if we look at creating a new item, we are creating a post request. To replace something, you use a put request. Put and patch are something of a similar thing, but put is updating the entire row of data, and patch is updating a specific column of that data. So you can either use put or patch whenever you are updating something, and you can use delete method to delete a certain item from the database. With methods understood, I think we can wrap up the concept of APIs. But to wrap this video entirely, you would also need to understand servers, as it is also a very important component of our backend stack. All right, so to understand servers, we will need a world map, and I've got one. So within this world map, I have built Claringo in India. Claringo's files and the backend, which is the APIs and all the functions, are within this laptop. I can run Claringo locally on my laptop. So let's say I have figured some way to send a URL to a friend who lives in the USA, and I've asked him to use Claringo. Note that I just sent him the link to the front end. So what happens is he tries to access something using that link and tries to do something of an action which requires a backend validation or authentication. So the data that will flow will take a lot of time to cover this distance. And Because of that time, the user will be frustrated, thinking that the app is not working. He might have triggered something, but it is not responding to him. For that, I will copy my backend and the functions entirely to multiple servers across continents. So here is one server. I would also create one server here. I would also have one server placed here. I will also have one server placed here. I'll also use one server which is probably here. So whatever data or backend functions that I had here is now also copied and deployed on these servers, which are nothing but stacks of CPUs, GPUs, and RAMs in a data center, which is local to whatever particular continent that we are targeting our users for. So now the distance between the uh, connection to the server, or basically the data transfer speed between our backend and the user using the app, is very, very less. So that is what server is all about. Server is a virtual system similar to our laptops and PCs, which hosted somewhere in the cloud remotely throughout the entire world so that users can access our application without facing any delays in the backend responses or app functioning. So yeah, that covers the entire concept of backend. And I hope this gives you a good clarity and probably help you in building your own products. See you in the next video. Thanks a lot for sticking around. Bye-bye.